In this chapter, we're going to take a look at linear equations in two variables. What makes them linear is that the variables are just raised to the first power. We're not squaring anything or taking a square root. We're not multiplying the two variables together. They appear like, for example, in this equation, 3x minus 7y equals 9. We just have a variable times, with a coefficient, and a variable with a coefficient. They're not multiplied together. We're not dividing by x or squaring y or anything like that. So we're going to focus on these types of equations and how to graph them. The graph of an equation, the graph of any equation is just a visual representation of all the x, y values, those pairs that satisfy the equation, that make that equation true. These are linear equations because if you find all the x, y pairs that make it true, it'll form a line. And a linear equation in two variables, if we write it in a standard form, looks like this: ax plus by equals c, whereas a and b are not both 0, so we need to have at least one variable, basically, is what we're saying. And the graph of this type of equation is always a line. And so if we know that we're going to get a line, one way to graph an equation is simply to find 2 points, right? 2 points determine a line. And often the easiest points to find are the x and y intercepts, because to find the x-intercept, we just let y equal 0, and to find the y-intercept, we let x equal 0, and those are really easy to plug in and solve. So for example, let's say we want to sketch a graph of the line 3x minus 4y equals 12. I'll start by getting the intercept. So the x-intercept, to find an x-intercept, this is true not just for lines, but for any graph. To find an x-intercept, you're going to set y equal to 0. If we set y equal to 0, we get 3x minus 4 times 0 equals 12. Of course, 4 times 0 is 0, so this boils down to 3x equals 12. We'll divide by 3. We get x equals 4. And so that means 4, 0 is a point on the line. And to find the y-intercept, we let x equal 0. So we get 3 times 0 minus 4 times y equals 12. 3 times 0 is, of course, 0, so this boils down to negative 4y equals 12. We could divide both sides by negative 4 and get negative 3. So that means that 0, negative 3 is the y-intercept. And now we'll just plot these 2 points and connect them with a line. And there's the equation of the line 3x minus 4y equals 12. An equation with just one variable will either be horizontal or vertical. So the equation x equals a, where a is some constant, is a vertical line. The equation y equals b, where b is some constant, is a horizontal line. So we could sketch these two lines on the same coordinate axes pretty easily, I think. X equals negative 4. Oops. That just means that the x coordinate of every point on this line is negative 4, and the only way that happens is if you've got this vertical line right here. Y equals 6. That is a line defined in such a way that the y-coordinate of every single point on the line is equal to 6, and that only happens with a horizontal line. One characteristic of a line is its slope and how steep it is. So basically that's what the slope gives us, is tells us how steep it is, whether it goes upward or downward as the line moves from left to right. If I know a couple of points on the line, say I know the points x1, y1, and x2, y2, we find its slope by just finding this fraction. y2 minus y1 divided by x2 minus x1. The difference in y's over the difference in x's, people usually refer to this as rise over run, which I'm going to sort of misspell the word rise on purpose here. This is just a reminder that the y's go on top. So if I wanted to find the slope of the line that connects these 2 points, 2, -3, and 5, 3, well, I'm going to begin just by writing out the formula. I've got to call one of these points my x1, y1, and the other point my x2, y2. It makes no difference how you choose to label them, which one is your point 1 and which one is your point 2. Just make sure that you plug them into, plug in the coordinates correctly into your formula. So in this case, y2 minus y1 is 3 minus a -3. On the bottom, x2 minus x1 is 5 minus 2. 3 minus -3 is a positive 6 over 3, so we get a slope of positive 2. When I think about a slope, I usually think about it in terms of a fraction. So I might, if I were kind of visualizing a line with slope 2, I think of it as 2 over 1. Like I go up 2 and over 1 from one point to get another point. If I have a couple of lines, L1 and L2, and they have their respective slopes, M1 and M2, those two lines are parallel if and only if their slopes are equal. So if they have the same slope, they'll be parallel. And they're perpendicular, meaning they cross at a right angle if and only if their slopes are opposite and reciprocal. So M1 is -1 over M2, or another way to write this is that if you multiply the two slopes together, you get -1. So possibilities for the value of a slope, if the numerical value of the slope, when you find m, if it's positive, that means that the line goes upward as x moves from left to right. If the slope is negative, then the line goes downward, or is falling as x moves from left to right. If the slope is 0, it's a horizontal line, and that kind of makes sense. Think about y2 minus y1 over x2 minus x1. If the slope is 0, that means that the y coordinates are the same, and so there's no change in y. On the other hand, if it's a vertical line, that means that the x coordinates have to be the same, and so x2 minus x1 would be 0, and you'd be dividing by 0, and that makes your slope undefined. If remembering back from some algebra courses you've taken, you may already be familiar with the slope-intercept form for the equation of a line, y equals mx plus b, where m is the slope and b is the y-intercept, or 0b is the y-intercept. It can be convenient for graphing an equation. So if I want to sketch a graph of the line 2/3 x minus 3, well, I get 1 point for free, right? So they tell us in this problem that the y-intercept is 0, -3. So I know a point that's on the line. And the slope is 2/3, which means from a given point, I can just go up 2 and to the right 3 to get a new point. So let's see this work out. My y-intercept is -3, so there's that point. And then I'm going to go up 2 and over 3 to get my next point. And then connect these lines. So here's a graph of the line y equals 2/3 x minus 3. Going up 2 and over 3, that's like a positive 2 over positive 3. You could also achieve the same effect, we should note, just by going down 2 and to the left 3, because that would be equivalent to negative 2 over negative 3, which is of course numerically equal to a positive 2/3. And you can sort of see how that just gives us a point in the other direction on the line. Okay, so in this next example we're going to look at some pairs of equations, figure out if these lines are parallel or perpendicular or maybe neither. And we're going to do that just by finding the slope. You can find the slope, if we go back up to this this definition of the slope-intercept form. If I have an equation and I just solve it for y, right, I get it in that form, then that will allow me to isolate the value of the slope. And once I know those slopes, then I can determine if they're parallel or perpendicular or maybe neither. So I'm just going to take each of these. So this will be equation 1 and this will be equation 2. Starting with equation 1, 2x minus 3y equals 15. I'm going to just solve for y. So I'll subtract 2x from both sides. That gives me negative 3y equals negative 2x plus 15. I will divide both sides by negative 3. So I get y equals. Now over here, remember I can split up a fraction over addition up top, so negative 2x over negative 3, and then plus 15 over negative 3. That is a positive 2/3 x minus 5. So there's the slope-intercept form for the first equation. For the second equation, 2x minus 3y equals negative 1. If I subtract 2x from both sides, I get negative 3y equals negative 2x minus 1, dividing both sides by negative 3. Negative 2x over negative 3, and this will be minus 1 over negative 3. This gives us positive 2/3 x plus 1/3. Now these slopes are equal. They're both positive 2/3, so that means that these lines are parallel. Down here at the next pair, got equation 1 and equation 2. So 2x minus 3y equals negative 1. So this equation right here, this is the same as equation 2 in the first example in part A. So for equation 1, this is y equals positive 2/3 x plus 1/3. And for equation 2, 15x plus 10y equals negative 8. Let's solve this for y. I'll subtract 15x from both sides, so we get 10y equals negative 15x minus 8. We'll divide both sides by 10. Now over here on the right side, again I'm going to split up this fraction over the subtraction up top. So negative 15x over 10 minus 8 over 10, and reducing, let's see, 5 goes into 10 twice and 15 3 times, so that's negative 3/2 x minus, and then 8/10 is 4/5. So now let's compare these slopes. 2/3, negative 3/2. So 2/3 and negative 3/2, these are opposite and reciprocal. The signs are different, and then one is flipped over from compared to the other one. So that means that these lines are perpendicular. Okay, let's try one more. So 2x minus 3y equals 15, and 3x minus 2y equals positive 1. So I'll just note that 3x, let's see, 2x minus 3y equals 15. This line right here is the same as this line up here from part A. So I don't need to kind of recreate that work. So that the slope-intercept form is y equals 2/3 x minus 5. And for the second line, we'll go ahead and solve that for y. So if I subtract 3x from both sides, we get negative 2y equals negative 3x plus 1. We'll divide both sides by negative 2. And splitting this up over the addition in the numerator gives us, let's see, negative 3x over negative 2 is a positive 3/2 x, and then minus 1/2. So now compare these slopes, right? 2/3 and 3/2. They're obviously not equal to each other, but they're also not opposite reciprocal. One slope is the reciprocal of the other, but same sign. So that means that this is neither parallel nor perpendicular. All right, so next they give us a line here in this example, 2.6. The equation of the line they give us is 2x minus 3y equals 6. They ask us to first write it in slope-intercept form and then sketch a graph. I mean, we could graph it without slope-intercept form like we did in the beginning. We could just find the two intercepts. But they're asking us to get it in slope-intercept form first. So 2x minus 3y equals 6. So to get it in slope-intercept form, that means we're going to solve it for y. So we'll subtract 2x from both sides, and then we'll get negative 3y equals negative 2x plus 6. Dividing both sides by negative 3 gives us y equals negative 2x over negative 3 is a positive 2/3 x, and then 6 over negative 3 is a negative 2. So that means we have a y-intercept of 0, negative 2, and a slope of 2/3. So once I start at the y-intercept, I'll go up 2 and over 3 to get another point. So there's negative 2. I'm going to go up 2 and over 3. And that'll get me my other point, which, as it turns out, that gets us the x-intercept, is at 3, 0. So there's a graph of the line 2x minus 3y equals 6. So we know about the standard form for the equation of a line. That's this part here. That's the standard form. We know about the slope-intercept form. That's this form right here. But there's another form that's pretty useful for when we're trying to find the equation of a line, and that is the point-slope form. We call it the point-slope form is because all you need is one point on the line. Any point on the line will do, and the slope. And if you know any point on the line and the slope, you could get an equation of the line just by plugging those values in here. So y minus y1 is equal to m times x minus x1. Here, x1 and y1, these are the known point. That's like the fixed coordinates that you know. And y and x, the plain old y and plain old x without a subscript, those are variables. Those stay as y and x. Where this equation comes from is pretty easy to see if we just remember the slope formula. If you multiply both sides by x2 minus x1, you get m times x2 minus x1 equals y2 minus y1, and it's basically that equation right there. So let's find the equation of a line that passes through the point. They give us a point, negative 1, 3, and is perpendicular to the line 2x minus 3y equals negative 1. So they don't tell us explicitly the slope, but we know it's perpendicular to this line. So what we'll do first is get this line that they give us, 2x minus 3y, in slope-intercept form. And in fact, we already did that in example 2.5. So in example 2.5, we found that this slope, or that this line, was equal to 2/3 x plus 1/3. So we know that the slope of this line is 2/3, the line they gave us, and that means the line that we're looking for, because it's perpendicular to this line, our slope is a negative 3/2. And that's because it's perpendicular. So we have our slope. They gave us a point. Now I'm just going to begin by writing this equation, y minus y1 equals m times x minus x1. I'm going to plug in my known coordinates, x1 and y1, and the known slope. So we get y minus 3 equals negative 3/2 times, parentheses, x minus a negative 1, so that'll be a plus 1. Now, if a problem does not specify the form that they want the equation of a line to be in, it's okay to leave it in this point-slope form. If you're doing a problem like this and checking results in the back of the book, usually they'll either write it in slope-intercept form or the standard form. So to get it in slope-intercept form is fairly simple. We're just going to solve for y. We'll distribute this negative 3/2, distribute your slope, and then add 3 to both sides. And negative 3/2 plus 3 is 6/2, so that's plus 3/2. So you could leave it in this form or in this form. Either is fine. In the back of the book, you know, they try to save space, so a lot of the time they'll just give the equation of a line in standard form, because usually if we write it in standard form, we try to avoid fractions. So if you multiply both sides by 2, you get 2y equals negative 3x plus 3, because on the right side, that when you distribute that 2, it'll just cancel those denominators. And then if you add 3x to both sides, you get 3x plus 2y equals 3. So any of these forms, unless they specify, unless you're asked to give your result in this particular form, any of these forms is okay.